This is the 6-1F lesson, which is focused on multiplying and dividing square roots. Before we start some problems, I'm going to just kind of give an overview of some things to think about as you go through this lesson. First of all, it is not good practice, and your answer will not be simplified if you leave a decimal in a square root. So if we come across something like this, it is best to write it as a fraction and then use techniques from this lesson to simplify this. Um, and that brings us kind of to the next point or thing that will show up in this lesson, which is that having a square root in the denominator is not allowed in your answer. And in the second half of the lesson, it will go over that. The first half of the lesson, square roots in the denominator should actually sort of self clear or self rationalize. They should turn out from an irrational number into a rational number where there is no longer a square root. And you'll see that again come up towards the second half of the lesson. A couple other things to think about is that if we see a fraction that has a square root in the numerator and denominator, or one large fraction like this, because the 6-1E lesson said that these were two valid steps with square roots. We might see it more commonly in this lesson as the square root of 6 over the square root of 3, that if both of these are in square roots, we can cancel the radicands, just like we can cancel fractions and say that this is square root of 3 over the square root of 1, which is just the square root of 3 over 1, because the square root of 1 is 1, which is square root of 3. Another thing, so that is a valid move, is that we can take a fraction that has a square root in the numerator and doesn't have a square root in the denominator. We actually cannot simplify this. We can't cross these off or cancel these. This is currently stuck. But what we can do is we can simplify the numerator. Square root of 8 is 2 root 2. And perhaps we've done that one enough to just know that. Otherwise, you use a factor tree or perfect squares. And now we can cancel the 2 and the 4 since they are both rational numbers, since they are both outside of the square root, whereas root 2 is irrational. So we'll cancel this and this, and we'll be left with root 2 over 2 as our final answer that is fully simplified. So those are some things to think about as you're going through these problems, that we can cancel if both parts, numerator, denominator, are in the square root, and that we can't cancel both parts here if one is in and one is out. But in the case here, we can cancel because they both were rational numbers. We're going to look at a couple of examples. Number 2, so the idea here is that we're going to start to multiply and divide. And we saw a property show up in E, which states that we can just think of this as essentially all of this being multiplied. And we can put it all under one large square root, or in a sense, we could skip this step and just multiply. 15 times 3 is 45. Y times y is y squared, and z times z is z squared. And then we would simplify this further. So 45 is 9 times 5, and this is a perfect square. That stays inside, is banished to stay under the square root or the radical. And y squared is a perfect square, so it comes out to just be y and z. And we'll kind of just clean up this final answer, 3yz root 5. So the first idea there is that we can multiply radicands, and we need to, and then we need to use this stuff from the E lesson to simplify this fully. Number 3, another technique is that we can multiply the rational parts and the irrational parts. This is essentially the commutative property of multiplication. So we can say that 12 times 4 times the square root of 10 times 2. And then we're going to simplify this. So 12 times 4 is 48 times the square root of 20 and 20 has in it a 4 and a 5. The 5 is a dead end, so there is a perfect square. That is a pair of 2's, or we can think of it as the square root of 4 is 2. And we get 96 root 5. Number 4, and with dividing, just like we talked about above, we have some options. And as we get better at doing these, we might know what to do, so we can try some options. It's sort of like clearing fractions or decimals in equations, but these are obviously expressions. So first option is, since these are both irrational or have square roots or have radicans, and they're both divisible by 3, I can cancel them. Or alternatively, I can try to factor tree 150 and simplify that. But it does work best in this problem to cancel. 3 goes into 150 50 times. We have square root of 50, because we have yet to square root this, over technically square root of 1, but that is just 1. And 50 is 25 times 2. So final answer is 5 root 2. You always want to keep coming back and double checking that our radicand looks and is fully simplified. And we also talked about how we don't want a decimal as our radicand, and we don't want the denominator to have a square root. And you can see that, like I mentioned, it's going to clean itself up, but towards the end of the lesson, it won't.